Welcome back. This is tutorial 6A question 4. In this question, we are asked to examine the Dtft of the impulse, and we want to ask why the Dtft of the impulse response is the frequency response for an LTI system. To answer this question, let's begin to let the impulse be an input xn into an LTI system and outcomes yn. And as you know, if the input is an impulse, the output is the impulse response, and typically we write it as hn. But why is this so? So let's start from the beginning. If xn is any input, then yn is actually x of n convolved with h of n, the impulse response. That is the equation, and of course we can write it in more details. Now, so this is the equation representing this convolution equation in detail. Now, if x of k is simply delta of k, then this all the values of delta of x of k become 0 except at time 0. So what it reduces to is x of 0, which is 1, because this is the value 1 at time n equals to 0, and all the other values being 0, x of k. Therefore, the only thing interesting is x of 0 multiplied by h of n minus 0, which is 1 times h of n. And now we see why the convolution equation, when you are given the impulse, will result back to h of n. So h of n is the impulse response. Now if we Fourier transform, discrete time Fourier transform this, we'll get h of omega, and this is called the frequency response. Why is this so? Well, remember that if we have the impulse and we perform a discrete time Fourier transform on it, then the impulse will get all 1 from minus pi to pi for all omega, and this value is 1. This is x of omega. The Fourier transform of an impulse is the value 1 for all frequency from minus pi to pi, and this shows that the impulse actually is all frequencies with a constant amplitude of 1 and 0 phase. So basically we are sending all frequencies into the system, and whatever comes out is called the frequency response, because what happened is that the frequency response is showing us how different frequencies will react when it is being passed into this LTI system. So let's have an example of a frequency response, and for example a frequency response have this shape from minus pi to pi for the amplitude, and for example this shape for the phase. Then basically what this frequency response tells us is how the magnitude will change and the phase will change with respect to this input. That is why the name is called frequency response. How different complex exponential at different frequency will change or will respond by this LTI system by its changing of its amplitude and phase. So the way to understand why the impulse is important is to study it at its frequency domain. At the frequency domain, the impulse is all 1 at all frequency. It has all the same amplitude and 0 phase at all frequency. Since this is the input to the LTI system, whatever comes out of it will also tell us how different complex exponential at different frequency will react. And when we say how, we're interested in how the amplitude is going to change as well as its phase. So this explains why the impulse and the impulse response will let us know the frequency response at the frequency domain. Thank you.